Hello everyone, this video is for week 9 topic 10 part 3 solving logarithmic equations and inequalities. This topic can be found on your modules on pages 133 to 139 and we will be discussing examples 1 to 3. For the lesson outline, we have solving logarithmic equations and solving logarithmic inequalities. So before we discuss how to solve logarithmic equations and inequalities, here are some strategies for solving logarithmic equations. First, rewriting to exponential form. So we have already discussed this, that a logarithmic form can be expressed as exponential form and vice versa. The second one, using logarithmic properties. Okay. And the third one, we have applying the one-to-one property of logarithmic functions as stated below. So what is one-to-one property of logarithmic functions? It says for any logarithmic function, f of x is equal to logarithm of x to the base b if logarithm of u to the base b is equal to the logarithm of v to the base b, then u is equal to v. Okay, so in simple words, so if we have the same bases, then we can immediately say that our arguments are equal. So you have u is equal to v. Okay. Now let us discuss example number 1. Find the value of x in the following equations. So for letter A, we have logarithm of 2x to the base 4 is equal to logarithm of 10 to the base 4. So in this case, by applying the one-to-one property of logarithmic function, since we have the same bases, we have 4, we can immediately equate 2x and 10. Okay? So we have, okay, from the given, we can equate 2x and 10. So we have 2x is equal to 10. Applying the properties of equality, we will be dividing both sides of the equation by 2 to get the value of x. So 2x divided by 2, we can cancel 2. What is left is x. And then 10 divided by 2 is 5. So x is equal to 5. But we are not sure if the value of x is really 5 unless we check. So our x is equal to 5. So by substitution, we have, okay, so we will substitute 5 to x. So this is logarithm of 2 times 5 to the base 4. We are not sure if it is equal to the logarithm of 10 to the base 4. So 2 times 5 is 10. Okay, so logarithm of 10 to the base 4 is equal to the logarithm of 10 to the base 4. So they are equal when your x is equal to 5. So therefore, we have the value of x equal to 5. Now let us discuss letter B. Logarithm of 2x minus 1 to the base 3 is equal to 2. So what do you think? So first we'll express 2 as the logarithm of a number to the base 3. Okay, so applying the basic property of equality, your 2 can be expressed as logarithm of 3 squared to the base 3. So remember, in our basic property of logarithms, okay, so we have the same base, 3, base for the logarithm and base of the argument. Immediately the answer for that or the value of that is 2. So your 2 can be expressed as logarithm of 3 squared to the base 3. Since we have now the same base, 3 and 3, we can apply the one-to-one property of logarithmic function. So we can equate now 2x minus 1 to 3 squared. Okay, so you have 2x minus 1 is equal to 3 squared. and 3 squared is equal to 9. And then what do you think? By applying the properties of equality, which is addition property of equality, we can have 2x is equal to 10. So we have 9 plus 1. So negative 1. We will be adding both sides of the equation by positive 1. So we have 2x plus 10. So it could be negative 1. This one will become positive 1. So you have 2x is equal to 9 plus 1, which is 10. And then we will divide both sides of the equation by 2. And the value of x will be 5. So 10 divided by 2 is 5. And then we will check our x is 5. So we substitute 2 to x. So we have logarithm of 2 times 5 minus 1 to the base 3. We will be checking if it is equal to 2. So we have 2 times 5 is 10 minus 1 is 9. And then we can express 9 as 3 squared. And then applying the basic property of equality, the value of this part of your equation is 2. The exponent of 3 is 2. So we have 2 is equal to 2. And since they are equal, therefore the value of our x is equal to 5. Now let us discuss example C. Okay, so we have logarithm of 16 to the base x is equal to 2. Okay, so we can have, what do you think? So we can express this as an exponential form. So x is the base, 2 is the exponent, and the argument is the answer. Okay, so the exponential expression, if we will be expressing this as exponential expression, that is x squared is equal to 16. So how do we solve for x? We'll be getting the square root of both sides of the equation. Okay, square root of x is equal to positive negative square root of 16, and the answer is x is equal to positive negative 4. But you have to remember that x is the base. Okay, x is the base, and we, according to the definition of the logarithm of a number to the base, b, your b must be greater than 1 or greater than 0 but not equal to positive 1. So since our x, the values of our x is equal to positive negative 4, our base can never be negative 4. So therefore our final value of x is equal to 4. We only take the positive value of x. Okay, but we are not still sure if the value of x is 4 unless we check. Okay, so let us check. Logarithm of 16 to the base x is equal to 2. Let us check if it is really 2. So we have, by substitution, our x is positive 4. We can express 16 as 4 squared. And then we have the same base 4, and the base of the argument is 4. Therefore, the value of this expression is 2. So 2 is equal to 2. Since they are equal, therefore we are sure that the value of x is equal to 4. Okay? Now we will proceed to example 1, letter D. We have logarithm of x plus 1 to the base 2 plus the logarithm of x minus 1 to the base 2 is equal to 3. So if you can observe, this is the sum of the logarithms of two numbers, which can be condensed as a single logarithm. So we have our base 2, base 2, so we can condense these two logarithmic expressions as a single logarithm. So plus, it means to say that this is the product of, or the logarithm of the product of the two numbers. So we have product of the two numbers, the logarithm of the product of the two numbers. And then by applying the one-to-one property of logarithmic functions, since we have the same base 2 and 2, we can equate this x plus 1 times x minus 1 and 2 cubed. Okay, so x plus 1 times x minus 1 is equal to, the 2 cubed is equal to 8. Okay, so by applying the FOIL method, this is x squared minus 1 is equal to 8. Okay, and we will be solving for the value of x. Okay, so we have x squared minus 1 minus 8 is equal to x squared minus 9. So your positive 8 becomes negative 8, and negative 1 minus 8 is negative 9. So equals x squared minus 9 is equal to 0. And then we will be solving for the value of x. This is a quadratic equation, so we can use factoring, completing the square, or we can use quadratic formula, but the best way is to use factoring. So we can have x squared minus 9, it can be expressed, can be factored as x minus 3 times x plus 3. And to solve for the value of x, we will equate each factor to 0. So our first factor is x minus 3. So x minus 3 is equal to 0. And to solve for the value of x is equal to 3. So minus 3, applying the addition property of equality, your x is equal to 3. Okay. And for the second factor, which is x plus 3, we will equate that to 0, and we will solve for the value of x, and x is equal to negative 3. So in this case, we have two values of x. We have positive 3 and negative 3. So let us first check if it is possible that our value of x is 3. Okay, so let us check. We substitute 3, so 3 plus 1 is 4, 3 minus 1 is positive 2. So we have 4 and 2. So since this is addition, what do you think? We can condense this as a single logarithm, so therefore we can have logarithm of 2 squared plus 1 is equal to 3. So your 4, we can express 4 as 2 squared. To get the value of this, so you just take the exponent, so you have 2, and then the value of this is 1. Okay, the exponent of 2 is 1. Okay, so you have 2 plus 1 is 3, and 3 is equal to 3. So since we have 3 is equal to 3, we can say that one of the values of x is positive 3. And how about if we have negative 3? Okay, so let us substitute. Okay, but if we have negative 3 plus 1 is negative 2. Negative 3 minus 3 is equal to negative 4. And in our previous lesson, in a logarithmic form, logarithm of a to the base b, a cannot be negative. So, negative 2 and negative 4 is, if we substitute negative 3, we get negative 2 and negative 4, which makes your logarithmic equation undefined. So therefore, we cannot have negative 3 as the value of x. And therefore, we have only 3 as the value of x. Okay, that is for example number 1, letter D. So now we have example number 1, letter E. Logarithm of x squared is equal to 2. Okay, so what do you think? How do we solve for the value of x? Okay, so remember this is 2. We will be expressing this as a logarithm of a number to the base 10 because our base here is 10. Remember, this is a common logarithm, and a common logarithm is a logarithm of base 10. So how do we express 2 as a logarithm of number to the base 10? So applying the basic property of equality, we all know that the base of this is 10. So for us to get 2, we have the base of the argument, which is also 10, and raise it to positive 2, so that by applying the basic property of logarithms, the value of that is positive 2, so which is the exponent of 10, the exponent of our argument. So therefore we can have logarithm of x squared is equal to the logarithm of 10 squared. Okay, and by applying the one-to-one property of logarithmic functions, we can equate x squared to 10 squared. So therefore we have x squared is equal to 10 squared, and 10 squared is equal to 100. To get the value of x, we will be getting the square root of both sides of the equation. Therefore we have square root of x squared is equal to positive negative square root of 100, and the square root of 100 is 10. So we have x is equal to positive and negative 10. So let us check if really the values of our x are positive 10 and negative 10. Okay, so let us start with positive 10. Okay, so substitute. So 10 squared is equal to okay, so the base is 10. If we substitute 10 to x, this will become 10 squared, and by applying the basic properties of equality, we have 10 as the base of the logarithm and 10 as the base of the argument. Therefore the answer for that is the exponent of the argument, which is 2. So you have 2 is equal to 2. So it means to say that 10 is the value of x. Okay, how about if our x is negative 10? Okay, so we will substitute the value of negative 10. So we have logarithm of negative 10 squared, and 10 squared is 100, and we can express 100 as 10 squared. So still the same concept, we must express our argument so that we can have the base of 10, because we all know that the base of our logarithm is 10. So it means to say that we have logarithm of 10 squared to the base 10. Okay, and still applying the basic property of equality, the exponent of 10 is 2, therefore the value of this logarithm is 2. So 2 is equal to 2, so therefore negative 10 is also the value of our x, and therefore we can conclude that the values of x is, or the values of x are positive 10 and negative 10. So for example 1, letter A, we have two values of x, positive 10 and negative 10. For example number 1, letter F, we have logarithm of x quantity squared plus 2 times logarithm of x minus 3. Okay, so what do you think? Okay, so if you will be looking at the equation, this is a quadratic equation, okay, of the form ax squared plus bx plus c is equal to 0. So we will be using the concept of solving quadratic equations. So let x be equal to a. So we will be substituting logarithm of x by a, so that we can have a squared plus 2a. So logarithm of x is equal to a, and then minus 3. So if you can see, this is in quadratic form. Okay, quadratic form, it is a polynomial of second degree. Okay, and then we will be solving for the value of a. So um, by using factoring, we can solve for the value of a. So we can factor this a squared plus 2a minus 3 as a plus 3 times a minus 1 is equal to 0. So by this time, I am expecting that you are experts in factoring. Okay, so again, the factor of a squared plus 2a minus 3 is equal to a plus 3 times a minus 1 is equal to 0. Okay, and we can equate each factor to 0. So we have the first factor, a plus 3 equals 0, and to solve for the value of a, so a plus 3, so our value of a is negative 3. So a plus 3 equals 0, applying the properties of equality, so the 3 will become negative 3. For the second factor, we have a minus 1 is equal to 0, so we have your negative 1 becomes positive 1. So applying the addition property of equality. So for letter F, in this case, we have two values of a negative 3 and positive 1. But remember, we are solving for the value of x. So this is not yet the values of your x, but the value of b, and but the value of a. Okay, so your a is equal to the logarithm of x. So still we will be solving for x. Okay, so the first value of a is negative 3, or this is logarithm of x is equal to 3. We will be still solving for the value of x. Okay, and same thing, we have the value of a equal to 1. This is also equivalent to logarithm of x is equal to 1. So we will be solving for x. Okay, so you have expressing this as exponential form. So we all know that the base of this logarithm is 10. Okay, so 10 raised to negative 3, this is the exponent, and the argument is the answer. So 10 raised to negative 3 is equal to x, and x is equal to 1 over 10 cubed. Okay, applying the loss of exponents, and then expand, the value of x is, you have 1 over 10 raised to 10 cubed is equal to 1000. So the first value of x is 1 over 1000. And then for the second value of x, we have logarithm of x is equal to 1. And then expressing this as exponential form, we have the base is 10, the exponent is 1, and the argument is the answer. So 10 raised to 1 is equal to x, therefore x is equal to 10. So 10 raised to 1 is 10. So in this case, we have two values of the x, 1 over 1000 and 10. Okay, and we will check if these values are really the values of x. Okay, so let us start with 1 over 1000. Okay, substitute, we have our x is 1 over 1000, and then another x, we have 1 over 1000. Let us see if it is equal to 0. Okay, so your 1 over 1000 can be expressed as 10 raised to negative 3. So applying the loss of exponent, so your 1000, 1 over 1000 is equal to 1 over 10 cubed. And then since we all know that the base is 10, so we will be expressing 1 over 1000 so that we can have the base of 10. So we can express 1 over 10 cubed as 10 raised to negative 3. Okay, and then we have 2. Again, so your 1 over 1000 is equal to 10 raised to negative 3. So we have still negative 3. Okay, so what is the value of this? Okay, logarithm of 10 raised to negative 3. Our base is 10, so therefore the exponent is the value. So you have negative 3. Negative 3. This one, still the value of logarithm of 10 raised to negative 3 is 3. We have still 2. And then minus 3. And then negative 3 squared is 9. 2 times negative 3 is negative 6 minus 3. So you have 0. So negative 9 minus 6 is positive 3. Positive 3 minus 3 is 0. So correct. So it means to say one of the values of x is 1 over 1000. How about if we have the values of x equal to 10? So let us check. So substitute, we have 10 as a value of x. And then we all know that the base is 10, so therefore the value of this is 1. The value of logarithm of 10 is also 1. We have 2, and then copy minus 3. So 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. 3 minus 3 is 0. Okay, so 0 is equal to 0. So it means to say that positive 10 is also the value of x. So in this case, for example number 1, letter F, we have two values of x. X is equal to 1 over 1000 and x is equal to 10. Now let us discuss example number 2. Use logarithms to solve for the value of x. So we have 2 raised to x is equal to 3. So since the direction says we need to use the concept of logarithms to solve for the value of x, we'll be expressing this as an equation of two logarithmic expressions. So by using the one-to-one property of logarithmic functions, we can have logarithm of 2 raised to x is equal to the logarithm of 3. So they are just the same. Okay, so since the concept of one-to-one property of logarithmic functions is if we have the same base, we can equate the two arguments. So we have 2 raised to x is equal to 3. Okay, and then by applying the third law of logarithmic third law of logarithms, the exponent x can be used as the multiplier. So we can have x times the logarithm of 2 is equal to the logarithm of 3. Okay, since you are asked to solve for the value of x, to eliminate logarithm of 2, we will divide both sides of the equation by logarithm of 2, so that we can eliminate logarithm of 2, and what is left is x. So x times logarithm of 2 divided by logarithm of 2 is equal to x. Okay, and then we also divide logarithm of 3 by logarithm of 2. So therefore we have x is equal to logarithm of 3 to logarithm of 3 divided by logarithm of 2. And then we will be using our calculator to solve for the value of this. Okay, so we have logarithm of 3 divided by logarithm of 2. So we have you have the logarithm of 3, and we all know that the base is 10. Okay, that is logarithm of 3 to the base 10 divided by the logarithm of 2 to the base 10. And our answer would be approximately 1.58. Okay, if we will be rounding our number or our final answer into two decimal places, or if we will be rounding our final answer into 5 decimal places, we can have, what do you think is the answer? In 5 decimal places, we have, it is approximately 1.58496. Okay, that is our example number 2. Let us now proceed to solving logarithmic inequalities. But before that, let us discuss first the properties of logarithmic inequalities. So given the logarithmic expression logarithm of u to the base b, we have two intervals for the value of b. So your b is between 0 and 1. Okay, between 0 and 1. And the other one, b is greater than 1. Okay, so greater than 1. You can find the value of your b here. Okay, so for b between 0 and 1, x sub 1 is less than x sub 2 if and only if logarithm of x sub 1 to the base b is greater than logarithm of x sub 2 to the base b. And if your b is greater than 1, we have x sub 1 less than x sub 2 if and only if logarithm of x sub 1 to the base b is less than logarithm of x sub 2 to the base b. So if you can observe, when your b is between 0 and 1, the opening of your inequality sign is reversed, while for b is greater than 1, the opening of your inequality sign remains the same. Okay, so for more of this, we will be discussing some of the examples. Let us discuss example number 3. Solve the following logarithmic inequalities. So letter A, logarithm of 2x minus 1 to the base 3 is greater than logarithm of x plus 2 to the base 3. Okay, so for the first step is to ensure that the logarithms are defined. So if you can still remember, for the logarithm of a to the base b, your a must be always positive. So it means to say 2x minus 1 must be positive and x plus 2 must be positive. So what does it mean? Since these two are positive, 2x minus 1 and x plus 2, so these two must be greater than 0. Okay, so let us solve for x. Okay, so 2x minus 1 is greater than 0, so that it will become positive, and x plus 2 is greater than 0 for this to be greater than 0 or to be positive. Okay, so we will solve for x. So we have 2x is greater than 1, applying the properties of inequality, addition property of inequality. Okay, we will add both sides of the inequality by 1. So you have negative 1 becomes positive 1. And then to solve for the value of the x, we will divide both sides of the inequality by 2, and your x must be greater than 1/2. Okay, so to visualize the value of x, we have a number line, And for x greater than 1/2, we have this part. Okay, so this is 1, this is 2, 1/2 can be found here. So the value of x must be greater than 1/2. So 1 is not included. Okay. On the other hand, if we have x plus 2 greater than 0, your x must be greater than negative 2. So where can we find this on your number line? So your x must be greater than negative 2. Okay, so your 2 is not included. Hence, we are using a hollow point. Okay, and the intersection of the two intervals must be x is greater than 1/2. Okay, so we cannot use x equal to -1 because in this part, or if we have -1 for this one, if we have -1, your argument will become negative. So -1, 2 times -1 is -1, -2, -2 minus 1 is -3. So the values of x could be found here with x is greater than 1/2. Okay, but it's not yet the final answer. Okay, so we will be solving for the value of the x. Okay, so we just ensure that our logarithms are defined by identifying the values of x, so that 2x minus 1 and x plus 2 are positive, or we could have the values of a to be positive. So but still we will be looking for the value of x. Okay, so step number 2 is to ensure that inequality is satisfied. So looking back at the properties of logarithmic inequalities, you can observe that our base, which is 3, is greater than 1. So it means to say your inequality sign is not reversed. Okay, so applying this property, we can use 2x minus 1 and x plus 2 on both sides of the inequality, but your opening must remain, or still we have greater than, okay, because our b is greater than 1. Okay, and we'll be solving for the value of x. So we will be using the properties of inequality, use the addition property of inequality. So we will combine similar terms. So you have 2x, your positive x will become negative x, and then you have 2, your negative 1 becomes positive 1, and 2x minus x is x, and 2 plus 1 is 3. So your x is greater than 3. Okay, so where can you find that in your number line? So x is greater than 3. Okay, these are now the values of your x, and we can find that here, and therefore the values of x would be the intersection of x is greater than 1/2 and x is greater than 3, and the intersection would be x is greater than 3. Okay, and therefore we can write our answer as x is greater than 3, or interval form. We have 3 greater than 3, and then it goes to positive infinity. Okay, so this is the interval form, but you can also use this as your final answer, this notation. Okay, Okay, so you can assign any values of x as long as this x is greater than 3. So you can use 4, 5, you can use 3.5, you can use 1,000, 1,000,000. Okay, so that is for example number 3, letter A. For example number 3, we have logarithm of x to the base 0.2 is greater than negative 3. Okay, so for step number 1 is to ensure that the logarithms are defined. So we have to see to it that your x must be greater than 0. Okay, so x must be greater than 0. So in your number line, we can find this in, okay, so this is the visualization where can you find x is greater than 0. Okay, so 0 is not included. Okay, so next we have to express negative 3 as the logarithm of a number to the base 0.2. Okay, and by applying the basic properties of logarithms, we can express negative 3 as logarithm of 0.2 to the base raised to negative 3 to the base 0.2. Okay, so we all know that if we have the same base, the base for logarithm and the base for the argument, the value of that is the exponent of the argument. Okay, so negative 3. Okay, negative 3. So your negative 3 can be expressed as this. Okay, so applying, or we can first express your decimal number, your base, which is decimal number, into fractions. So this is 2/10 can be expressed as fraction as 2 over 10, or if we will be simplifying that, that would be your 2 over 10 is equal to 1/5. Okay, so let us express that first decimal number to a fraction. Okay, so applying the properties of logarithmic inequalities. Okay, so we have to ensure that the inequality is satisfied. Okay, so what does it mean? So if we will be applying this property, you can see that our base 1/5 is between 0 and 1. So that would mean our inequality sign is reversed. Okay? Okay, so from greater than, it will become, it will be reversed and becomes less than. Okay, so getting the arguments of the inequality, we have x and 0.2 raised to negative 3, which is equal to 1/2, and this 1/2 can be expressed as, or I mean 1/5 can be expressed as 5 raised to negative 1 raised to negative 3. So we can simplify this further as x is less than 5 cubed. So negative 1 times negative 3 is positive 3. And then as you can see, your inequality sign is reversed. Okay? And therefore, we have 5 cubed is equal to 125. So where can you find that in your number line? So from here, we have 125 and less than. Okay? So this part. Okay, so you have up to negative infinity, less than 125. Okay, but earlier we have discussed that for x must be always positive, or x must be greater than 0. So therefore we will be considering the intersection of x is less than 125 in x is greater than 0, and that would be this red one. Okay, so the intersection would be x is greater than 0 but less than 125, or x is between 0 and 125, or in interval notation, this one. Okay, so you can use any values of x as long as this x must be between 0 and 125. So always remember, 0 and 125 are not included in the solution. Okay, so that is for example number 3, letter B. Okay, and the last one, we have example number 3, letter C, negative 2 less than logarithm of x less than 2. Okay, so first step is to ensure that the logarithms are defined. Okay, so it means to say that our x must be positive or x must be greater than 0. So again, in your number line, this part is, or this part are the values of x. 0 is not included since the value of x is always positive. Okay, so number 2, ensure that the inequality is satisfied. So first, we can express negative 2 as the logarithm of the number of a number to the base 10. Okay, remember that our base is 10. This is common logarithm, and at the same time we can also express 2 as a logarithm of a number to the base 10. Okay, so your negative 2 is here, applying the basic property of logarithms, and your positive 2 is here. Okay, so again, your base is greater than 1, so it means to say the inequality sign is not reversed. Okay, so the inequality sign is not reversed. So we can separate this, okay, these two. So that would be logarithm of 10 raised to negative 2 is less than logarithm of x, or another one is we can separate also these two. Logarithm of x is less than logarithm of 10 squared. Okay, so let us see, we have the values of x. So again, the inequality sign is not reversed since our base is 10. Okay, so we will solve for the values of x. Okay, so 10 raised to negative 2 can be expressed as 1 over 10 squared, and you have x is greater than 1 over 10. Okay, so this is the first value of x. We have this interval, and the second one we have, or we can find that x in your number line, we have greater than 1 over 100. So you can find it here, and then greater than. On the other hand, we have, okay, so this one. On the other hand, we have x, logarithm of x is less than logarithm of 10 squared. So we have x is less than 10 squared. 10 squared is 100. Okay, so you can find that here on your number line, 100, and then you have less than. Okay, so therefore, where can you find the solution set of this inequality? Okay, so we have 3 intervals. Okay, greater than 0, greater than 1 over 100, and you have less than 100. And therefore, the intersection of the three intervals must be your x must be between 1 over 100 and 100. Okay? Or this is the interval notation. Okay? So you can only find your set of the solution set between 1 over 100 and 100. Okay, so that is for example number 3, letter C. Okay, so for this video we have discussed how to solve logarithmic equations and inequalities. Okay, so I hope you have learned something out of this. Always remember the properties of inequalities, the laws of the inequalities to solve for the logarithmic equations and inequalities. So that's all. Thank you very much.